y'all? Back to some more math. We're talking about integrals as exponents. So there's two main parts to integrals with exponents. There is, of course, our base. In this case, will be the a. This is our base number, meaning that the main number that everything is being made up of. And we have the exponent, this top number up here. Now our exponent, as it works here, is telling us how much of something. Now, for any integral with the exponent of 0 or a negative number, we say this separate. So most of these will always be a positive number. But let's talk about real quick negative and 0 exponents. If it's a 0, any exponent to the 0 value will always give us a value of 1 regardless. This could be negative 100 to the 0 power. It could be 1 over 13 to the 0 power. It still always gives us 1 regardless. Now, to a negative value, when you have a negative value, what this does is this becomes a fraction. It moves it. So right now this is a to the negative m over 1. So what this is going to do is just force this whole exponent to move down to the denominator. And if it's in the bottom, it moves up. So for example here, we a to the negative m over b to the negative n. They swap place it, and the exponent, exponent goes with it. Now, once it moves, it does become positive exponent, and then we can work from there. But let's look at these exponents as they are. So this is telling you the value, the concept of a to the negative n is telling you that there is that many a's multiplying with each other. Now, how many a's is determined by what's the value of this n. So let's look at this. So like we did just right now, we have 6 to the 0 power. 6 to the 0 power, anything to the 0 power we said is 1. Alright, now let's look at 4 to the negative 5. So this is 4 to the negative 5 over 1. Like we said, to make this a positive, this whole value will go down into the denominator. It'll switch, so this becomes 1 over 4 to the 5th. Now we can simplify this. This is saying that we have 5 fours multiplying each other. So if I break this apart, this is what we're saying. 4 times 4 times 4 times 4 times 4. So 4 to the 5th, like this, is the same value as taking 4 times 4 times 4 times 4 times 4. So let's see what that is. So if you take 4 times 4 times 4 times 4 times 4, you get 1024. This is our final answer here. Now let's look at this last one. So you guys do this last one. You can pause this video, do it real quick. Alright, I'm going to work on this. So, just like before, because of these negative values, we're going to move this. That means we're going to move this x down, this y down, and this z will go up. But remember, these exponent values will also go with them. So, on top, we should only have the z to the 10th power. On the bottom, we have x to the 3rd, y to the 8th. And these are positive. Now, because these are letters, not integers, then we're done right there. That's as simplified as it can get. Alright, so that's exponents. Well, how we work with exponents. Now, property of exponents have different things. So if you're multiplying two exponents that have the same base, you can see the same base, then you can just add those values up right there, n plus n. So for example, 3 to the 2nd power times 3 to the 5th power is the same thing as saying 3 to the 2nd plus 5th, which gives us 3 to the 7th, and then we can factor this out. Now, if you want to leave it in exponential form, we can do it like that. If they want to expand it or they want to simplify it, then we multiply 3 with itself 7 times. Now, a power of a power, so if you're multiplying, if you have a to the m to the n power, sometimes you'll see that like this, a to the m to the n power, so it looks like it's higher up, but side by side as well, also well. You then multiply these right here. So for example, 2 to the 3rd to the 2nd power is 2 to the 3rd times 2. So it gives us 2 to the 6th power. 6th power there. Now, power of a product is almost like a distribution concept. So let's say we have, in this case, just numerically, we have 4 times 3. We just distribute that 3 right there. So it's 4 to the 3rd, 3 to the 3rd. Now, let's imagine we have 4x squared. So that's saying 4 squared times x squared. This is where you'll see it the most, when you have a number and a variable on the inside. You'll see this quite a bit sometimes. Like we just said, negative exponents, they switch position. Goes bottom up, top to bottom, bottom to top. So 5 to the negative 2 becomes 1 over 5 squared. Zero value, again gives you 1. Zero exponents of 1. Now, this is what we haven't talked about yet. So let's say we have the same base right here, but they're in a fraction. So here is a to the n power over a to the n. You can subtract the value. You can just subtract them. Now, the way we've done it before back in elementary is like, oh, we can just expand them all out and cancel them out. So here, this is 3 to the 5th, 2 to the 2nd. So 3 to the 5th minus 2, that should give us 3 to the 3rd. Well, let's expand that out, see whether that's true. So on the top, we'll expand this out. So we have 5 3's. On the bottom, we have 2 3's. For every 1 3, cancels 1 on the top. Every 1 on the bottom cancels 1 on the top, leaves us 3 to the 3rd power. So this is expanded, and this is just the normal short math doing this. And again, just like the top right here, if you have an exponent on the outside of the parentheses, you can distribute it in. That also happens in fractions. You distribute to both the top, the numerator, and the denominator. So a over b to the n power is a to the m over b to the n. For example, we have a 3 and a 5, so it becomes 3 to the 4th, 5 to the 4th. Alright, so let's kind of practice those right here. So like we said, same basis, then we just do simple math, negative 5. This becomes y to the negative 5 plus 3. So negative 5 plus 3, that gives us y to the negative 2. You subtract those two numbers, and again, this is not completely satisfied because we cannot have a negative value right there. So this becomes 1 over y squared. We're done with that. Alright, let's look at this next one. So let's look at just the numbers. Any other problem, if we just look at the numbers, we have 48 over 16. As we did before, hey, what can go into 48 and 16? 16 can. 16 goes into both of them. So 16 goes into 16 one time. 16 goes into 48 three times. So we're left with 3x to the 12 over 1x to the 4th. Now, just like before, these have the same basis, so we can bring this up and subtract it. So we got 3x12 minus 4. 12 minus 4 gives us 8. So our final answer is 3x to the 8th. Alright. Now, like we have right here, we have a power to a power. This is the same thing saying t to the negative 3 times 5. We multiply it, so that gives us t to the negative 15. That's a negative number, so we cannot leave it like that. So this would go down to the denominator form, gives us 1 over t to the 15. Now, same concept here. We're going to distribute this. Now, there is two different things right here. There is a 2. What exponents does this 2 have? It's a 1. Yeah, when there's no number on that value, then it's understood 1. This negative 2 is strictly on the s. So we'll distribute that 5. That gets us 2. 1 times 5 is 5. S negative 2 times 5 is negative 10. So this gives us then negative 10. Again, the only thing we got to simplify, or two things. We first got to get rid of this negative exponent, so it becomes 2 to the 5th over s to the positive 10. Now, s to the positive 10. Now we can also expand it. Since we're simplifying completely, then we need to go ahead and expand this. So 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32 over s to the 10th. This is simplified. Alright, let's look at this last one. It's going to take a little bit more work. So we take that negative 3, we're going to expand it to everything. So there's this value right here, 45 that has a 1. It's 9 that has a 1. That's it. Everything else already has it on there. So they go to the 1, to the negative 4, to the 2, to the 1, and to the negative 8. Right there. So let's see what that does for us. We first just go ahead and distribute. You get 45 to the negative 3. X now to the positive. So negative 3 times negative 4 gives us a positive 12. And then y 2 times negative 3 is negative 6. All over 1 times 3, y to the negative 9 to the negative 3, and then negative 8 times negative 3 is z to the positive 24. Positive 24. Alright, so let's now get rid of the negative sign. So this whole thing, let me change colors so we know. This whole thing will go down. This one will go up. And then this one will go down. Everything else will stay in the spot. So this 9 to the negative 3 becomes positive 9 of 3. Okay. And then we got x to the 12th. That stays where it's at. And that's it. On the bottom, we have 45 to the third. The y came down, so we y to the positive 6, and then z 24. Last thing we need to do is reduce right here. So on the top, 9 to the third. I start with bottom. Yeah, 9 to the third, so 9 times 9 times 9. That gives us 729 x to the 12th. On the bottom, 45 times 45 times 45. Get a big number, 91125. And then y6, z to the 24. And then just reduce it. More than likely, let's see if 729 can divide into. So 91,125 divided by 729. Oh yeah, it goes into it evenly. So 729 goes to 729 one time. It goes into this 125 times. So our final answer here on the top, all that's left is just x to the 12th. The bottom, we got 125 y6 z to the 24th. And we are done right there, y'all. Alright. That was a lot of work on that one, but I understand you will have some problems like this in your homework, and it kind of helps you take your time and then do everything right. Last one right here. We'll talk about order of operation in case you forgot your order of operations. Remember, PIMDAS. So please excuse my dear Aunt Sally if you don't remember that. So what this is saying is there's 4 levels. There's the parentheses. This is always first. You always do parentheses first. Then exponents. Then multiplication and division. Then addition and subtraction last. Now, multiplication and division are at the same level. So when you get to this, you work left to right. And addition and subtraction are on the same level, so then you work that left to right like you would anything else. So we'll start with parentheses problem. We always look at parentheses. Alright, here's a parentheses. We do all the work inside the parentheses first. In the work saying here we're saying 8 minus 6. Get a 2. Alright, so now we have 10 divided by 2 plus 9 times 4 over 2 to the 5th minus 3 squared. Alright, so no more parentheses, so that's gone. So next up is exponents. Is there any exponents? Yeah, right here. 2 to the 5th. Okay, so 2 to the 5th becomes what, class? Yeah, 32 minus 3 squared is 9. So 10 divided by 2 plus 9 times 4. Alright, then we look at multiplication and division. Multiplication, division, oh yeah, so we got division here. So 10 divided by 2. 5 plus, then we got 9 times 4. 9 times 4, 36. Then 32 minus 9. Now the last thing is addition and subtraction. We have some addition on top, subtraction on the bottom. Now, also remember, you do all the things on top first, and then you do all the things on the bottom with themselves. So if there was another multiplication division, we would have done that down here. We get our final answer to have a single number on top, which is 41, and a single number on the bottom, which is 23. Can we reduce those? No, we're done right there. And that's it. Okay, so remember your order operations. As you do this with these particular problems right here, you got to make sure you work your order operation. They'll put some multiplication, some addition in there just to see if you're paying attention. But hopefully that helps. That's all we're doing today as far as assignment. Have a wonderful day. Bye.